now have these fancy new calculators. And I think that it's important that we know how to use the calculators to solve systems. Because the first couple of sections in this chapter deal with solving systems of linear equations. And basically you're looking at, yes sir?
Are these notes we should have on this paper?
No. Well, I'm not going to have you graph graph these equations by hand. I will have you graph inequalities by hand because you'll have to shade. But these things, when I ask you to graph, I'm expecting that you guys take the calculators out and we're going to press some buttons.
Oh, so it's all of the calculators.
Pretty much. But here's the thing. What's going to happen here today is that we're going to be looking at a systems of equations. And if you guys remember, it was stuff like this. And I don't know. You had stuff like that. Vaguely remember seeing that? And if you recall, one of the first ways that you guys learned how to do this was to go to a graph, plot it, and try to figure out where the two lines intersected. And you hoped your lines were straight and you overlapped on the same point. Otherwise, you were halfway between a point and you had no stinking clue where you were. Vaguely remember that?
No.
I remember solving it. I remember.
Remember solving algebraically?
Yeah.
Yeah. Well, what I want to do today is we're going to do the algebraic stuff tomorrow. And I know most of you guys are looking at this going, oh, I just do the algebraically, be done with it real quick. That's great. I still want to show you how you can check your answer on a calculator. So what's nice about with the calculators is that there's a button on there that's the magical button of the calculator. It says
Y equals?
y equals. So what you want to be able to do with all these types of problems is to get the equations solved for y. Now, some of these are going to be really simple to do, and a lot of times you guys might be able to figure it out in your head as you're writing it out. So this first problem, let's see, what do I have to do? I just have to subtract 2x, and I get y is negative 2x plus 8. Do we agree? I'm going to do the same idea with the second one. I'm going to subtract 10, add 2, divide by 2, so I get 1/2 x plus 5 is y. Okay. All I did there, there's a couple ways of looking at it. And 2y and divided by, oops, that should be a negative. Divide out, I get 1/2 x minus 5, excuse me. So now from here, what I'm going to do is go to my calculator, and there's some fancy buttons that we're going to press. So we're right to the y equals. And I apologize, when I'm on this emulator thingy, it just takes forever. It's very slow. All right. So we have the ability to type in a bunch of equations. Each time we do this, we're just going to go 2 at a time. It's just easier. So the first one here, I'm going to type in negative 2x plus 8. Please don't forget to use the negative symbol, not the minus symbol. You'll get an error. And the next one would be the 1/2 x minus 5. Remember, in order to type in your calculator a fraction, alpha y equals, hit enter. Or if you want, you can just put it in parentheses. And then from there, all we have to do is hit graph. Now, with any luck, it should look like that.
Oh, look.
Does it look like that?
No.
A little.
Good. Now, if your window has been shifted over or whatnot, do you guys know how to adjust what it means to adjust the window?
Control.
No, it's not Control-Alt-Delete. If you hit the button that says window, normally set up in these types of graphs when we're using these things, we set them as a 10 by 10 grid. So your maximums and minimums for your x values should stay at 10. The scales and all the others should be at 1. So if what you're able to do here is you can move the window of the graphing calculator to kind of see where they run into each other. Yeah, without pressing the button that says zoom. I don't ever use zoom because it just makes everything nasty. So here's what we have. Right now we're all looking at a graph, and we see that those two lines intersect. Do you agree? Okay. Now, there's a real fancy button here. If we hit second calculate, where it says trace. Everybody see that? There's a button that says intersect. It's above trace. Top row. All right.
Thank you.
Pick 5. Intersect. And now it's going to ask you a series of questions. It asks you for your first curve. Hit enter. What this means by first curve, second curve, remember how I said that you can put in 8, 10 different graphs? You could pick which ones you want to work with. By just putting in 2 at a time, you don't have to worry about it. First curve, second curve, yep. The next button is guess. It's not raining. And there's your intersection.
You have to hit yes.
Just hit enter one more time. Basically, all you do after you hit the button for number 5 for your intersection, you hit enter then 3 times. And you get your intersection at 5.2 and negative 2.4. Obviously, this worked out to be a fractional intercept because I just made up the equation off the top of my head. Sometimes you'll get that like that. Sometimes you're going to get integers. That's all we're doing, guys. Yeah, yes, ma'am. Okay. No, that's fine. What happened was that somebody had used that calculator for like a program. What I want you to do is press the following keys. Second, plus sign, 712. Now do this following keys again. Second, plus sign, 722. And that is your control, alt, delete, restart. What happened here is that you're able to now, the equation you just put in your y equals, for her obviously, the equation that you have for y equals are gone, but you've reset everything. You restored it back to normal. Okay? And that's how you're able to do that. So what we're doing here, guys, we're trying to figure out how they intersect, where they intersect, and all that. So there's a couple questions I have for you then. Let's try this one. Once again, we're not using graph paper. We're solving for y, and we're going to use our graphing calculator to try to figure out the intersection points, if they intersect. And that allows us to do that. Pause this message going. So, are they the same line?
No,
Not
there's
at
negative and there's
least.
a different intercept. And
Oh, well, where was their intersection point then?
negative 1, yeah,
Where was it?
Negative 1, 3. Negative 1. You're so off.
Negative 1 and 3?
Yeah.
Did we agree?
Yeah. At least.
Very well. Okay. Now,
Yeah.
hold on a second here. So, we just said something. I'm not.
Am I wrong? You can't solve that.
So, the second one, we were just told that they are parallel.
Yes.
So, are there any solutions?
No.
No solution.
Not even.
Yeah, the first one's infinite because they're the same line.
Correct. The first one is an infinite solution because it's the same line. Yes, sir.
Does that mean like infinite?
So, alright, the two on the left,
These guys right here, yes.
they're a pair together.
Yes, they are the same exact line. When they're the same line, you have infinite number of solutions because they're lying on they're in the same spot. So you get to draw the good old-fashioned hyperbolic paraboloid. Did I tell you that story?
No. What's a hyperbolic parabola?
A Pringle. A potato chip. The guy that invented Pringles, and this is not a lie. I'm prefacing this. The guy that invented Pringles was a math guy. He was sick and tired of the bags of chips. When you get to the end of the bag of chips, they're usually broken. When you wrap them back up in the counter or put them back in the cabinet, take them out, they break. Right?
Yes.
So when he thought, like, why you need to think of a way to put them in where they don't break. So he had a cardboard cylinder. Well, if you stack them flat, they're going to break. When you put a curve to something, curves are very, very structurally strong. So he came and he used a hyperbolic paraboloid. Is the shape of a Pringle, which holds, they don't break.
I can see it.
Like when you look at
That was the whole idea. What happens is when you're on a grid, if you're graphing the same spot, they have infinite number of solutions because they're lying on top of one another. So the number of solutions is infinite. Yes, sir.
Do they break
Oh yes, I was so burned. I was treated.
Oh, at least you guys well enough to acknowledge.
Wow. Anyway, let's do it differently. The reason why I like to work with the calculators a lot of times is that you wind up sometimes with ones that just are nasty to put onto a into a graph.
Right?
I mean, if I'm looking at this one right here, I don't know about you, but I sure don't want to try to graph that by hand.
I never did.
And I know that you're looking, you could probably look at that and say, okay, I could solve that algebraically, probably without too much of a hassle because you've got opposite signs on the y value. But what's going to happen on a test or a quiz, I'll give you a problem that will deal with fractions and weird things, and I'll ask you to solve it graphically, which means I want you to use your calculator, and that's it. I don't want you to try it. The other reason why I'm showing you guys how to use the calculator stuff is because tomorrow when we go into, I told you I was telling the truth.
Yeah.
Ha!
Is that the twerk?
I was telling the truth. So the other reason of knowing how to use your calculator to do this is because that way you can check your results when you do these things algebraically. Because it is very simple to get lost in the algebra and go back and double check. Okay?
Yeah.
Told you. The internet doesn't lie. I'm French.
Oh, yeah.
Bonjour. Yes,
Are
sir.
you a French model?
Bonjour.
That's. Do we? Are there gonna
Oh,
be?
that's a commercial.
Yes.
I know that sound travels a little bit slower than light, so I'll give you that one because you're only, like 17 feet away.
I think it's more.
Couple times.
Question.
Yes.
How many? Are we gonna have to know how to do it algebraically?
Yes. And we're gonna get into the algebra stuff tomorrow.
It's okay, so do I have to solve that right
Please use your graphic
Oh,
calculator.
we're doing.
I'd like you to use your graphic calculator to solve that. Well, yeah, you would.
Nothing.
So what you do is you want to get y by itself.
Yeah.
Get y by itself, and that way, and now use your calculator. Okay. In the first one, we wind up with 3y is negative 14x plus 16. So we get y is negative 14 over 3x plus 16 over 3.
Yep.
On the other one, we get negative 5y is negative 7x plus 34. So I get y is 7/5
that's what I
x
did.
minus 34 over
That's what I
5.
did.
What's going to happen a lot of times with you guys when you're solving these types of systems, you're going to screw up on a sign. You're going to forget when you're moving stuff around what's still negative and what's still positive. So from here, it's just a matter of typing things in and using the alpha y equals for your equation. So what we got? What is it? Alpha y equals negative 14. Whatever. It's whatever. I know. Stupid machine. Takes forever on that thing. It's very simple to do that.
I know how I just I did it in the other one.
I subtracted the equations from each other. Wait,
That's when you do algebra. When you do the algebraic, otherwise if you use y, you get y equals 1.
That's about the same.
What'd you guys get?
Two negative ones.
2 negative 1?
I tried to solve algebraic one. No, 2 negative 4. There we go.
All right, let me see what we did here.
No, look at my calculator. This doesn't. Did you get the negative 3.7? No, I get negative like point.
Because you don't have negative, it's negative 14.3.
Oh, it's so
But that's okay.
why negative 12 is
Wait, okay, I
That
have
is
that.
plus 16 minus 8.
I have that.
right?
No, that's right. Negative 7 divided by negative
Process
2.
itself. Well, 16 minus 68 is
Oh, that's right. Yeah.
68 minus
Good, because that's the answer.
Because I was tracking those, and I should have been I got it. Okay.
You have a negative in front of the first one. You wrote negative negative. You
And
double
that screwed
negative.
up the answer that much.
Yes, because I got negative 7 y.
All right. Now, this also, in this chapter, we also get into systems with word problems. And there are quite a few of them as we go through. And what I want to do is this first day of work with word problems is really very basic. Now, I still want you to be able to use a graphing calculator to solve some of these things because it's quicker. Well, it's not so much always quicker, but it's easier to make sure that you're getting used to using the calculator with the right process, because when you go to the algebra version, you can always check. All right, you can always check. Make sure that that fractional amount you just got was correct. Things like that. So in here, what we want to be able to do is go through all the wording and try to figure out what are the 2 types of things or 3 things that they're working with. As we start these things today, we're looking with 2 variables and 2 equations. By the end of this chapter, we'll have 3 variables and 3 equations as well. So today we're talking about going to Florida for 7 days. It's going to cost you $275 a day in Tampa, $400 in Orlando, and for the 7 days you have $2,300 to spend. So when you read through that, you basically have 2 things that you're being constrained by, if you will: the number of days and the amount of money. Do we agree? Sure. All right. Now, how many days can you spend? 7. So we're going to say X amount of days in Tampa plus Y amount of days in Orlando is 7. Not bad.
I like it.
If I said X for Orlando, Y for Tampa, would that be terrible?
Nope, you just have to make sure that.
You have to know.
And that's where I'm going. That's exactly where I was going to go with the next statement. If I flip-flopped them around and said X was Orlando, that means everything else that I deal with Orlando relates to the X variable. So the biggest mistake that a lot of people do is they flip-flop. So whatever one you identify as your X variable, just keep it through the entire problem. So the next part you've got, it's got to equal up to $2,300. Same idea. It's $275 a day in Tampa plus $400 in Orlando. And then you wind up with system of equations again. Yes, sir?
Oh, so you gotta use both.
Yeah.
Oh, I
Because they're-
one stage more than one.
Right. So what happens is you get the 2 equations. And all I'm doing is solving for y. Like that. Now, do I need to worry about simplifying fractions to enter them in the calculator? No. There's no reason to it. There's no reason to. I mean, obviously, if it's 2 over 4, could you just put 1/2? Sure. But what I'm saying is a lot of times you don't even have to worry about wasting your time. So all I gotta do is type in negative x plus 7, and then the other graph I do my negative 275 over 400, x plus 2,300 over 400. And I'm of the old school, I usually use parentheses if I'm doing it by hand on my own calculator, because alpha y equals too many buttons. Graph it. You should still be able to see this on your graph. If you can't see it on your graph, it means you just got to move your window. Second, calculate, 5, enter, enter, enter. 400. That's it. The calculator is going to allow you to do these things real fast. Because I don't know about you, I don't think you want to graph that by hand. I mean, I know that we can do our substitution and solve, which we'll be working on tomorrow, but at least we're remembering how to go back to the calculator to double check our work. That's the main idea today. Okay. Not so scary? I didn't hear you. What was that?
Christian said 4 and 6 and
That's real close to Florida.
What about the place?
Lastly, let's just talk about how to set this one up. Your school is planning a 5-hour outing, a 5-hour to the park. The park rents bikes for $8 an hour and inline skates for $6 an hour. Your budget per person is $34 an hour, or $34. How many hours should students be spending doing each activity? Now, remember, going rollerblading and biking sounds like a hoot for 5 hours straight, doesn't it? It's how I want to spend my day. What are the two types? What are the two things you have to be comparing here? We have time and money, right? Okay, x plus y equals 5. All right. Take it to the next step, Richie. What do you got?
Alright. It's gonna be 8x plus 6y equals 6.
From there, could you solve for y and use your calculator?
Yes. At least.
Looks a lot like the other graph. What'd you get?
Hold on. Slow down.
Is it the
2 and 3.
Grab the wall. I think that's what we're dealing with.
2 and 3.
This
Why
is
did
so
I get
similar, I
3
know,
too?
except one was coming from a higher.
Very good. All right.
Let me see what
So
I get.
tonight, all I want you guys to do, I have on page 140. I think it's 142.
Was it x is 2, y is 3?
Yeah. On page 142, this is section 3.1, numbers 26 through 31. Just use your graphing calculator.
Wait, so we don't have to like write it?
You'll probably have to solve. You still have to solve for y on a lot of them, but I'm not asking. You don't have to do algebra. Just solve for y. And then the other ones are 54 through 58 and 65. Okay.
All in 3.1.
Yeah, it's all 3.1. Yeah, that's what.